Good morning students and welcome back to this class, same class on long division method. So last class you might have seen about long division method, finite terminating decimal. Long division method, finite terminating decimal. So today we will be seeing about long division method, non-finite terminating decimal. Non-finite terminating decimal. So in long division we have two types. One is finite terminating decimal, another one is non-finite terminating decimal. So first we will be seeing about a very simple example, a simple problem. That is, find the decimal representation of 8 by 3. So this we will get a non-terminating decimal. So this is a very simple problem. First we will see a very simple problem. So when you solve this problem, solution, keep the 8 inside and outside we take the denominator 3, 8 divided by 3. Now you can see here 8 is 2 times less than or greater than 3. 8 2s are 3 2s are 6. So we get a remainder 2 by normal division. Then you place a point here and add a 0. Since 2 is less than 3, you bring down this 0 here. So now 3 5s are 15, 3 6 are 18. So just place a point here and keep it 6 here. So it becomes 18. 3 6 are 18. So again you get 2. So you can see again it's repeating the same number. So again we will try to solve one more time. Bring a 0 here. By keeping a 0 here, we bring this 0 here. Then 3 6 are 18. You can see here it becomes, the balance is again 2 when you minus this. So if you same 2 is coming again and again as a repetition, so it is not, it will never terminate. So this number will never terminate, and that's why it is called as non-finite terminating decimal. So when you find by means of a long division method, when it is not terminating with 0, you get it, it keeps on repeating, means it's called non-finite terminating decimal. Therefore the answer for 8 divided by 3 is 2.666, and it keeps on going on. So it will be written as 2.6 bar. So answer is 2.6 bar. Once more, keep 8 inside and divide it by 3. So 3 2s are 6. You get a remainder 2. Place the point decimal here as well as a decimal above. It's 20. Bring a 0 down. 2 6 are 18 divided by 18. Then subtract it. You get 2. Then bring again the 0 down. You get 2 6 and 3 6 are 18, and you get a remainder 2. Since it's not terminating, so we call it as non-finite terminating decimal. So it keeps on going on. Afterwards it comes, always it will come as 0.666, and it keeps on going on 6. So we make it as 2.6 bar. So now we will be moving to the second problem, which is find the decimal expansion of 1 divided by 7. Find the decimal expansion of 1 divided by 7 by long division method. So we are taking in this again the long division method. So write it as solution and place inside 1 and outside you place 7. So dividend will be 1 and divisor is 7. So 1 is much less than 7, so we cannot divide. So what we do means we just place a 0, place a decimal. Before that, if you want, you can place a 0. Then you add a 0 here, so it becomes 10. Now what you do means 10 is greater than 7, so 7 ones are 7. Since 10 is greater than 1, you can divide it. So 7 ones are 7, you give a remainder 3. So now 3 is less than 7. So what you do means you add another 0 and bring that 0 down. It becomes 30. So 30 is greater than 7. So 7 fours are 28. So now if you when you subtract this 2, you get 2. So 2 is less than 7. So you need another 0. So place the 0 next to it. So 20 is greater than 7. Again divide 20 divided by 7. That is 7 3s are 21. So it will be lesser than that. 7 2s are 14. So you get a remainder 6. So 6 is less than 7. So again you place a 0 here. You can bring it down here. It becomes 60. 7 5s are 35. 7 6 are 42. 7 7s are 49. 7 8s are 56. So you can get it 56. When you 7 8s are 56. So you get a remainder again 4. So 4 is less than 7. So place again a 0 here and bring that 0 here. 5s are 35. Then divide it like this. Subtract it. You get it 5. 5 is less than 7. 5 is less than 7. So place a 0 here and bring that 0 here. 7 7s are 49. Again comes 1. So you get a remainder 1. Then place a 0 here and bring that 0 here. So 7 1s are 7. And you get a remainder 3. So this 3 is again being repeated here. This 3 is again repeated here. So you get a, when you again continue, the same thing will be continuing one by one. So we cannot terminate this. Therefore, the decimal expansion of 1 by 7 is 0.142857. 0.142857. So when you put a bar over that, again it will be repeating. This much numbers will be repeating from 142857. Again it will come 142857 and it keeps on going on. So this particular area will be repeating. So it is a non-finite terminal decimal. So thank you students for watching the video of long division non-finite method. If you forget it, remember the Bible verse Genesis 1:14, second part. God divided the light from the darkness. So this verse is a non-finite terminating decimal. That is, the light is divided from the darkness and it keeps on repeating. Thank you for watching. Thank you.